All right, folks, time once again for the only coast to coast radio show that's all about the information economy. It's time for Inside Analysis. Yours truly, Eric Kavanaugh here. And I'm very pleased to have an expert in observability with us today. We have Todd Persen. He's with a company called Hydrolix, the CTO over there. We're going to talk about observability for highly regulated industries. So, first and foremost, what is observability? I've watched this space explode over the past 5 years. It's amazing how quickly it has spun into action. And there are various reasons for this. I think Kubernetes out of Google has a lot to do with it because Kubernetes opened up this amazing federated compute paradigm where you can spin up these little containers with little system processes in them and be able to scale out compute very, very quickly and very efficiently. But also, it opened up all these Pandora's boxes of observability. So, we're trying to look at various information systems to understand what they're doing. Now, historically, you couldn't see a whole heck of a lot. You'd be looking at histograms, for example, of CPU usage or memory usage or network traffic or basic things like that. And you had to kind of correlate it all yourself in your head to figure out what was going on to do troubleshooting. But now with observability, you can see so much data. And there are big players in the space. There are players like Data Relic or New Relic rather, and Datadog is one. And there are some really interesting companies like Mesmo we've done some work with where they actually sit on top of other observability solutions and allow you to kind of route the traffic of the data because at first there's not a lot of data and you think, oh, we have enough storage for that. And then after like 6 months to 9 months to a year, guess what? You got a whole heck of a lot of observability data that you're paying for to store, and it becomes a bit of a menace. So with that, Todd Pearson, I'm going to bring you in, in highly regulated industries, financial services, healthcare, insurance, of course, these types of things. It's really important to be on your game and to know what's happening in our environment. Is something bad happening? Is the system going down? So observability is really crucial for these information systems. Maybe start us off by telling us your take on this and the role that hydraulics plays in facilitating observability.
Yeah, for sure. Yeah, thanks for having me. So I think one of the things that's it's interesting about highly regulated industries. You kind of have to remember they have the same tools as all the rest of us. They're still using a lot of the same data infrastructure. Like they have to run the same technologies, but they have a higher regulatory bar. They have to be able to show things to stay in compliance. They have to be able to track usage patterns and be more on top of of threats and breaches and things like that. And so observability, and I think you mentioned the last 5 years kind of seeing it explode. And I would say modern observability, like sort of the term observability really has been, I think, in practice for about 10. But we seeing more and more ways to get that data from the systems that we're running, either whether it's emitted from your application or from your infrastructure or custom metrics that you're emitting. And so, obviously those data volumes have grown, but for these regulated industries, they have more things that they need to keep track of, and they have to do it at whatever scale, is required. They don't have the benefit of being able to say, well, I'm just going to say that that's less important to my business, so I'm not going to worry about ingesting those metrics or ingesting those logs. They still have to do that. And so one of the things that we see a lot is, where, a normal like B2B company may just say, hey, I'm just going to send all my logs to a New Relic or a Datadog or whatever. That may not work in highly regulated industries. There may be, PII, there may be other kinds of like secure information that could potentially like be covered under HIPAA that you actually maybe need to keep on-prem or need to keep in your own highly regulated data center. And so there are a lot of these solutions out there where that's a non-starter, where you can't just say, "Hey, I'm just going to go take Datadog and I'm just going to run it myself," because that's not how it's built. And so one of the things that we're seeing here with hydraulics, and I'll get to our sort of like core value in a second, but we're seeing a lot more interest as our company is growing, where we have whether it's telco, whether it's financial services, insurance, healthcare, where that desire for them to be able to take the same technology that we run for our customers in a managed service, take it and run it themselves, be able to deploy it, manage it, and so half of that is a technical challenge, like can the bits go where they need them to go and run in whatever environment they have. The other part of it is just like how do we teach them what it's like to run this system in production, to scale it, in the event that there is an incident. How do they go through and find the information that they need and really and get the value out of that system? And so Hydrolix broadly is a streaming data lake for logs. And so we see logs in particular as one of the kind of like most important lenses for observability when we're looking at data exhaust from all the systems that are running, but
Hmm.
also being able to track a lot of these use cases and really get insights into what's going on. And I think if you rewind the clock a little bit further, like pre-observability, we had things like Splunk. Splunk's been around since 2002, 2003, something like that. And logs sort of were always there. Metrics and distributed tracing and sort of these more modern observability concepts are much newer. And so logs have always been there, despite having, things like tracing. People still lean on logs for almost everything. It's almost impossible for
Right.
people to really
Right.
divorce themselves, even if they have an organizational posture to reduce log volumes. It's difficult because it's just such an easy way to get information out of systems. And so Hydraulics really focuses on, hey, we've watched these data volumes grow year over year. We're still seeing double digit percentage growth year over year. Um, the number of sources, like you said, Kubernetes, this whole microservice containerization push really just created so many more places for logs to be emitted.
Right.
And so, yeah, and it's just going to
Right.
keep growing. Like we keep finding more services, more things to glue into. And so really our focus has sort of been on how can we take uh, the volume problem with logs, use a focus architecturally on object storage is our kind of our storage destination. So saying, we see that there are huge cost savings to be had with object storage. And if we can put everything in object storage and not be reliant on SSDs and this sort of like hot cold tiering concept that we see in a lot of other products, we can
Hmm.
get really good performance out of object storage, but we also have the cost savings and long-term retention aspects of object storage. And
Yeah,
so,
and
yeah, go
real
ahead.
quick, like so object storage versus file storage, for example, you lose some granularity when you go to object storage, but you're able to capture that back somehow, right? And are you creating indices as the data comes in, or like how do you enable the near real time analysis of data when you talk about like a streaming data lake? How do you actually enable the analytics side of that equation?
Yeah, that's a great question. And that's a lot of that honestly is what our focus has been kind of on our core IP has been, when you have a local SSD, obviously there are some IO advantages there. You get higher, theoretical throughput from a local disk. The downside though is that you have to manage those disks. If you want to scale up an environment and you need more capacity, you have to add more disks. And
Mm,
so with object storage, it's designed as, whether you're using it from AWS or GCP or you're running your own like Minio or something like that, it's like theoretically perfectly elastic. You pay for what you use. If I want to send you, 5 terabytes or 500 terabytes, I don't need to ask you to provision more storage. The system, the object storage like infrastructure handles all of that for you. And
mm,
so the sort of like realization was that if we do, like you're saying, if we figure out how to index the data in a way where we have some um, you know codified knowledge of like what files exist out there, what time ranges are covered, and we have ways to build these indexes that we can go and look up at query time which of those files in object storage have the relevant data. We can actually do some query parallelism because of the way object storage is designed, and we can actually get higher overall throughput than we can with local disks in some cases, and we can get comparable query latency. And
hmm,
so we're able to keep data at the same resolution, same granularity on object storage as other systems would on local disks.
hmm,
But you as an operator don't have to manage those disks. You're just reliant on that object storage tier. And because of a lot of the innovations that we've done on indexing, compression, and query parallelism, we can actually get comparable performance. And so you do this at query time. We don't need to rely on any fancy caching. We actually can just go and in real time, yeah, pull those indexes, do the query plan, and go pull the relevant like sections of files from object storage and pull those query results together. So it's, and I mean,
Yeah.
a lot of it is it's sort of the beauty of the age we live in, where there's this technology that initially seemed like it was really just for like archival storage. But a lot of the innovations from these hyperscalers have given us a lot of tools where if you use object storage right, there's actually a lot of
Hmm.
performance to be gained there. So that's kind of
That's
how it works under the hood.
Yeah, that's really interesting, and it shows that you're paying attention to what's happening out there. And this, I think, is one of the challenges for software developers and for CIOs everywhere. Is just staying on top. Like I read the other day that state is now supported in some of these storage systems, which is kind of an interesting deal because Kubernetes, of course, is stateless. And just to remind our audience, when we talk about state, we're talking about a multi-stage process. Like when you're shopping online, for example, at Amazon, you're in the state of searching for things. And then when you go to buy something, you switch state over to the purchase process. And of course, you execute the trade, you send them your money, you get your stuff. But knowing where something is in a stateful environment is really important. And so now that these storage environments support state, I was like, wow, that's kind of interesting. I mean, you have to be cognizant of these things to know how to adjust your architecture, your stack, what you're doing, because you can save a lot of money if you do it right. You can save yourself a lot of trouble. I mean, really, the simpler the stack, the better as a general rule, right?
Yeah, and I think that's the state piece is something that I think is really interesting for us. So in designing a scalable system, state is a lot of times your enemy because,
Mm,
when you have state, you generally have contention. And that means like, if you've got one source of truth, which is sort of what when we're talking about state, like you were talking about the state of a checkout flow or something like that, or I mean, another good example is like a bank account. Like there is a true balance of your bank account, a true set of transactions that represent the state of your bank account. And you don't want there to be places where you can have race conditions where two things can be fighting to make an update at the same time. So you have
hmm.
this is why transactions are so important in like ACID compliant databases, because you need that isolation to guarantee that like if this update happens, no other update can preempt it or overwrite that update and cause something to be
Right,
lost. But
right.
in distributed systems, especially ones that are high scale, state is very challenging because if I have um, let's say 100 workers that are all ingesting data, those all are going to be, and each one of them has to take in some data and then update some sort of catalog or sort of system of truth or whatever about which pieces of information it has. The more of those you have competing for state, the harder it becomes to scale. And so, in a lot of the design choices that we've made, it has been about how can we minimize the competition for state resources, and how can we simplify that tier as much as possible. And so, I mean, and this is going to be familiar to anybody who's working in like large scale distributed systems. It's like how do I minimize the amount of conflict and let
Right.
that work be divided up. And so that's another thing that we've worked really hard on. And I think it's something that when we look at um, observability data in general, like especially with the data volumes that we're starting to see out there that are becoming common, it's becoming a really important part of the design choices that you make when you're building these systems. Because I think so we just did some work with Fox for the Super Bowl. We were looking at all of the CDN traffic for all the online streaming users for the Super Bowl,
Yeah,
and
that's
we were
crazy.
doing it was crazy. It
That's
was
amazing.
amazing, and it was I think we were ingesting, I think close to, I think 16 or 17 gigabytes a second of
Jeez.
just log data. And this isn't the actual stream data, which was
Right,
also a lot. This is
right.
just the logs that are coming from all the devices that are streaming data in. And so,
Wow.
if we kept that rate, for an entire day, it would have been a petabyte and a half in the course of one day. That's just logs for one event for one customer.
Right.
And
And log
that's,
files are really, really small. I mean, like
yeah,
the average
yeah,
log file is just a little bit of text, right? It's not
yep.
like
Yeah. And I
it's
mean,
not like an
even
image or a video.
right, right, totally. And so that's the scale that we're starting to see a lot of these systems grow to, because we have so many active users on a lot of these systems and so much, concurrency. We also did another event there was like a cricket world final or something like that. And it was some several hundred million concurrent users that were watching that stream. And so, but this is becoming more common. And I think we're seeing this with logs as well, with observability data, where people generating a terabyte a day, that used to seem like a crazy amount. And now we regularly see large organizations easily generate over 100 terabytes a day. And I think
Right.
there definitely are companies out there doing a petabyte a day regularly, but I think that's also going to become something that's not all that uncommon. Like that'll be a regular pattern we see in the Fortune 500, and especially some of these bigger, media entertainment companies as well.
Right. I just looked up, I was trying to remind myself when App Dynamics got bought by Cisco and everyone's
Yep.
jaw hit the ground, $3.7 billion. And that's 2017. Back then, it was a lot of money,
Yep.
right? These days, it's like, a billion here, a billion there. Databricks buys Tabular for $1 billion. You're like, what do they have, 5 accounts? Like, and it's like an open source standard. And you're like, all right, hold on a second. Iceberg is the open source standard, and then Databricks just bought Tabular for $1 billion. Let me wrap my head around that. Like it's wild what we're seeing. We got a break coming up here in just 1 second, and Todd, in the next segment, I want to get into you a little bit more with details around use cases because there are tons and tons of use cases for observability. There's performance, application performance management, APM, which is still a huge space. And App Dynamics is just one of many companies in that space. You mentioned Splunk, which is typically viewed in security circles, but they do lots of other things too. There's cloud cost, there's fintech, in Finops, for example. There's a lot of stuff happening in Finops these days. So there are all these examples. And then, of course, hybrid cloud. You got your on-prem environment, you have all these different cloud, and I joke that we went from talking hybrid cloud to talking multi-cloud in about 2 days because everyone realized, okay, it's not just on-prem and one cloud. It's on-prem and like
Yep.
5 cloud providers, right?
Yep.
GCP, Amazon, Azure, Rackspace, Oracle. It's like it's everywhere. How do you deal with that? And the answer, in short, is observability. Well, folks, don't touch that. We'll be right back in just 1 minute. We're talking to Todd Persen of Hydrolix. You're listening to DM Radio. All right, folks, back here on Inside Analysis, Eric Kavanaugh talking to Todd Persen. That's Persen. You should look him up online on LinkedIn. And we're talking about observability and all the different use cases. Well, I always, when I try to explain tech issues to family or friends or other folks, I always try to really distill it down to some basic experiences. And the most common is when you're on the phone for customer service and someone's like, I'm sorry, our system is slow today. It's like, oh, why is that? Why is the system slow? Is the database slow? Is the network slow? Is the application slow? Are you getting hacked? What's going on out there? It could be any one of those things. And that's the blessing and the curse of the complexity of the systems that we have these days, because you have all these interdependencies that sometimes stretch from on-prem into the cloud or into two clouds, and all these API connections going, stringing together transactions and trying to manage state and do all these different things. And that's what we're talking about. So I'd be curious to know, are there sweet spots for hydraulics? Is it mostly like cloud infrastructure or is it application performance management or just a mix, or what do you see?
Yeah, so we have a pretty deep relationship with Akamai. So they were kind of one of the early leaders in the CDN space,
Hmm.
and they've obviously expanded into security use cases, and they have a compute platform as well. They bought a company called Linode a couple of years ago, and so
Right.
they're continuing to grow that business, and they have a lot of the largest websites on the planet. So they see a lot of traffic, and one of the places that we offer a product that they sell called Traffic Peak, and we are basically taking in these CDN logs, these application firewall logs, and we store that data. And so the reason that those use cases are particularly interesting for us is that it's transactional data, and so these customers really care a lot about getting the full fidelity of those CDN transactions.
Hmm.
And so a lot of the places where we position hydraulics are places where you really want to retain the full resolution of that data. You really
Mm.
want to see each transaction. You want to be able to go in the event that there was an issue and go back and look and see. okay, this particular user had an experience that was bad. How do we go fix that, or how do we resolve that, or what was the root cause? We see less, and this is just kind of an industry trend. We see less of the specific like application and infrastructure logs. You
Mm,
mentioned Kubernetes. It does generate a lot of data, but I think in a lot of cases, the specific individual log lines are often less important, and they're less important for to keep for long periods of time. When there's
mm,
an outage, you want to go and be able to see, okay, this thing is failing. But oftentimes, if something's broken, you don't get one error message, you get like a million. So
right.
it's very easy to see the thing that's broken, even if you're there are some tools out there that sample observability data and things like that. So we don't see as much emphasis put on those application infrastructure logs just because there are other tools that can kind of handle those or do some shaping of that traffic volume. We see a lot of
Right.
interest from again, like these transactional logs. I think you mentioned just before the break, Finops financial use cases. There's a lot of interest there, especially in the security world. If you're looking at um, these individual transaction logs, and it could be these CDN logs, these like actual logs from users coming in at the edge. Those are a rich source of information for threat detection. If you're looking to kind of figure out what happened during an incident, you realize that your system was hacked. How do you go back and figure out what the origin of that was? And if you're
Right.
missing any of those like individual transaction logs, you could be missing a key piece of that information.
Right.
And so
Interesting.
this is the place where we see a lot of room for us to continue expanding. Is security is just kind of a natural extension of a lot of the work that we do with Akamai and other companies right now at the edge. Um, I think again, any of these regulated industries in particular, where you as an organization need to be able to go back and say whether or not something happened, and sometimes the retention periods for these things are multiple years. That's a great place for hydraulics to be positioned, because going back to our kind of first segment when we were talking about object storage, the cost of retaining data in object storage is very low. And if you're looking at records that you need to keep around for long periods of time that have little or no query overhead, it costs you very little just to keep those stored indefinitely. And
Hmm.
as long as those are around within hydraulics in our format, you can go back and query that data at any point. You don't have to, some other tools are designed in such a way where you have the data, but then you have to go out to object storage and you have to rehydrate that data. And it takes
Right.
like an operations team to make the data available, and then it's
Right.
only available for a certain period of time. So with hydraulics, because we're object storage only, the data that's out there is queryable at any point. So if you realize there was a breach 9 months ago, you can go jump right into those logs the same way
Hmm.
you would with the logs that we ingested yesterday. And so the focus for us is really finding those use cases where data volumes are massive, retention is kind of a top priority, and scale is really a challenge for a lot of other products, because those are all things that we do incredibly well. And for the interesting thing that we've noticed is that a lot of these companies that are coming to us with data challenges, they bring up cost, and it's not necessarily that they want to save money. They just want
Mm,
to get a better value for what they're providing. And in a lot of cases, they're happy to keep spending, in some cases, like $1 million plus a year on log management is not unheard of. They're fine spending that amount of money, but they want to be able to solve some other business challenge like these retention issues and things like that, and not have to pay for a secondary tool to enable that. And so really, the spend is there, the budget is there, but being able to get more bang for your buck, as they say,
right.
and be able to do a lot more of these things with one tool is really compelling for a lot of these companies.
Yeah, and you bring up a really, really good point here too, and I'm just going to extrapolate here and theorize that, you can't do the analysis unless you have the data. And if you don't have the data, or if there's this process you have to go through to get it, like you said, going out and having to rehydrate, get a data engineering team on the job, I mean, that takes time, it takes effort. And then by the time you get it all together, maybe the problem has been solved anyway. But I seem to think there is a tremendous opportunity now, especially as as we mature with machine learning and artificial intelligence to do some deeper analysis on the data. So yeah, you got it. Your primary use case maybe was security or infrastructure management, and someone starts getting into FinOps, you realize we're pulling all this data. So if you have a team that you can dedicate to just kind of play around with this, almost like a sandbox, and start looking for other opportunities, that's a real treasure trove of information to play around with, right? So the use cases can expand over time on that same data, right?
Yeah, definitely. Yeah, you brought up a whole bunch of really good points there. So I think one is, that we see this sort of pattern in a lot of companies, the concept of like dark data, where, you've
Right.
ingested this data, but maybe it's just sitting in a zip file somewhere in an S3 bucket. And,
Right.
data discovery on that is virtually impossible. You either have to know that it's there, or you have to ask somebody to go and like pull it down and figure it out. And so when you actually really want to get answers, that is an incredible challenge. So in some ways, things like, standard formats like Parquet, or you mentioned Iceberg earlier, it helps to have some of these things, and you can run like a Spark job to go dig through this data. But, even if you have that data somewhat active, discoverability is hard, like especially within logs, it's not easy to know what your what the data is that you even have, or like what field contains the information that you're looking for. And so I think one of the big I think challenges, especially as these data volumes grow, is how do you enable that kind of discoverability of data, and how do you make it possible for people who know that they need to find something, but they need to spend some time, you know, looking through various time ranges, looking through different sources of data, and being able to actually kind of like start with limited knowledge and sort of build a picture as they kind of do that discovery process. And then another piece is, and I think you sort of were touching on this as well, is that we see obviously like Splunk is still the biggest player in the logging space, at least certainly from a revenue perspective, and now also part of Cisco along with App
Right.
Dynamics, and that was a
Right.
$28 billion deal,
Right. It
which
was
is
unbelievable.
also crazy. Um,
Unbelievable.
but we see a lot of companies, again, huge data volumes, and Splunk is has a lot of tools for helping you do work with unstructured data and do those kinds of things. But the problem is that, again, with the way Splunk is built as like from an architectural perspective, you end up in a lot of these situations where the system is built for a certain set of daily use cases, a certain alert volume, a certain dashboard volume. Um, and then you have somebody who wants to do this like, model training, or some sort of like, hey, I've got this pet project. I want to go pull a whole bunch of data and run some analyses. And all of a sudden, the Splunk instance that the security team uses to do their job every day, they're like, no, you can't have access to that, or no, you can't put that kind of query load on my Splunk cluster. And you get all this
Mhm.
pushback from teams that say like, well, we can't support that, or you get rate limited. I've heard that a bunch of times, where some AI researcher wants to build a model, but then can't get enough
Hmm.
query capacity against Splunk to actually get the data that he needs. Um,
Right.
and so one of the things that we've also designed, kind of with these use cases in mind, is that you can, because going back to the stateless design we talked about, it makes it relatively easy to say, hey, I want to, just for today, spin up a bunch of extra query capacity so that I can, and even have a dedicated pool of query workers. You can go do that, run your analysis on the data. Again, it's all on object storage, and we're effectively unlimited in terms of like network throughput to that actual like object storage backend, thanks to the work that the hyperscalers have done to build these technologies. And so
Hmm.
there's a lot of room for flexibility there. Whereas in a lot of these older systems, again, you've got a much more stateful cluster design, especially for these companies that are running their finely tuned Splunk clusters. It's not easy to just double your query capacity for a couple days and spin it back down. That actually takes a lot
Right.
of operational effort and a lot of cost.
Interesting.
And so yeah, that's just the thing that we see, kind of to your point about just there's a lot of discovery and model training and things like that I think people are starting to want to do with that log data.
Yeah, no, that's really cool. So, I mean, could I describe hydraulics as, in many ways, the fire hose? Like, you're the
Yeah.
fire hose, you connect to all the operational system, then you just shoot that data into object storage. You enable, I'm sure, certain kinds of analysis, but you are an enabling technology for all these kinds of analytics, whether it be for analyzing log files or tracers or whatever the case may be, right?
Uh, that's right. Yeah. And so I think the fire hose description is perfect. So our goal really is to you know get all that data in as fast as possible. And I think for kind of going back to the Super Bowl example, we were ingesting all that data at a relatively significant, rate, but then also at the same time, we were still, I think, our ingest latency, so time from us receiving the data to it being queryable was, just a few seconds. So there's
Right.
no, some systems have these 5, 10, 15-minute lags before the data is available. So not only
Mhm.
is the data available in real time, but we still were able to offer, sub-second, query latency for, I think there were something like 55,000 queries like during the event that were run against the data that we were ingesting. And so,
Wow.
all that stuff was happening in real time. And I think, the way that we see it, back to the fire hose analogy, is that bring all the data in hydraulics, and we're not going to be super opinionated about like, oh, you have to use our dashboards or our, whatever. So we leverage Grafana, for dashboard visualization for a lot of our customers. So we've
Hmm.
got an integration built with that. We've got an integration with Spark and Databricks so that you can use those tools if that's how your ML teams want to run their analyses. We use the SQL parser from ClickHouse actually as our kind of query front end. So we support ClickHouse SQL, and we've got just a lot of integrations with these other tools to make it so that we want to be that data source, and then we don't want you to have to like rewrite your tools or rewrite your dashboards or do all this work to um, make it work. We want to be that back end.
Yeah, that's a really, really good point to make. We've got about a minute left in this segment, but we'll bring Todd back here in just a moment and talk about why you would want that level of data. Why would you would want that much? Because think about the Super Bowl. How much money is involved in the Super Bowl? Like how many advertisers are paying how many millions and millions of dollars? That is mission critical stuff. Like you do not want that feed breaking. You want everything to work perfectly. And that's why you pay that much attention because, what's the old expression? Luck is when opportunity meets preparation, right? It's like you weren't lucky that bad things didn't happen. You prepared to get ready for this such that you're there. And when bad things start happening, because, hackers, they're all over the place. They're constantly causing trouble and just all sorts of other issues. Nodes going down, servers going down, hardware does break. This does happen. Things happen in the real world, stuff breaks. So you want to be able to prepare yourself to handle that. And that's exactly what we're talking about, this fire hose of observability data, which can be used, as we suggested, for a whole bunch of different use cases. But you can't analyze the data if you don't have the data. Well, folks, stand by. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to a very knowledgeable Todd Persen. He is the CTO for Hydrolix. They are, as I described them, the fire hose of observability data. If you have lots and lots of data, we're talking about CDNs a lot, content delivery networks. So, how you get your streaming, your Netflix, your Apple iTunes, all this stuff, that's all going through these CDNs that are all over the place these days. And there are data centers and more data centers coming. And, Todd, one of the really interesting developments I've seen over the last 4 or 5 years is FinOps. What does this stuff really cost us? When you have this software as a service model, you're paying on consumption. Well, like, how do you know what that consumption is? I mean, you can read database files, you can read network traffic, you can do all these different kinds of things, but we're getting very, very good at being able to understand how much did that really cost when you ran that query. Well, that wasn't the case 5, 10 years ago. I mean, everything was on prem. And so you could handle whatever you could handle. And it wasn't really, people didn't think about FinOps so much. But once you're in the cloud, because I'm sure you remember the whole mission or the whole promise of the cloud was, oh, it'll work and it'll be so much less expensive. You're going to be saving money. It's like, "Oh, are you sure? I don't know." Some people going back to repatriating data centers because it's expensive in the cloud. But now you can get to FinOps. So talk about how Hydraulics enables FinOps.
Yeah, and I think the cloud challenges that you're describing, I think there are obviously, AWS, GCP, Azure, like those businesses are all just massive in terms of how much revenue they generate every year. And I think for a lot of companies, um, maybe that don't necessarily have the expertise to run their own data center, or they're not at the scale. I think it's a great tool to have available to be able to just like go to AWS, pick your set of services, deploy your stuff, and you're good. But I do think we'll continue to see a lot more of these companies reevaluating kind of their overall like TCO, and we see some with some companies as well that are looking at capex versus opex, and there are some financial reasons to consider racking up your own hardware and keeping things in your own data
Right.
centers.
Right.
But I think I think at the heart of it, like observability is just giving you more insight into all the aspects of your systems. It's on one end it's service health, looking at things like reducing MTTR in the event of an outage and kind of your
Right.
business critical stuff, and then all the way into the back office, and you're talking about kind of FinOps, cost optimizations and things like that. And so, we've seen there's obviously a bunch of companies out there now as well that are doing these sort of like cloud cost optimization is their product. They pull data from all these different sources and help you figure out how to save money. But I think underneath the hood, it's all some form of observability data. We're looking at
Right.
like these
Right.
utilization metrics and these events, and figuring out when did something scale up, when did something scale down, what am I
Right.
actually using? And so I think it's not one of our core use cases as a company right now, but it's certainly something that I see is gonna continue to grow. And especially I think back to comments we made earlier, like all of these microservice oriented and kind of like orchestration layers, like you've got so many different moving parts that it's
Right.
just going to become a bigger and bigger data problem. And so yeah, yes, you have the systems that are running to observe and make sure that they're functioning properly, but then there's all that sort of like second order effects of like now I have to monitor the systems that are running my systems. And
Right.
yeah, I think
That's
you're totally
funny.
right. And so I see a huge role for that in observability going forward, and I think it's an evolution. It's maturing. We're getting to the point now where at least we have kind of the tools and techniques in place to run these systems. Now we're
Right.
starting to get better at observing those systems and
Right.
plugging into more like BI functions. And I mean, and we have some manner of this stuff internally as well, where we've got we use our own product to monitor our hydraulics cluster. So we're doing some amount of that internally, where a bit of the sort of the proverbial dog fooding, where we like want to make sure that we're testing our own stuff for these other use cases, but we believe we've got the best product and technology for this use case, so that's what we're using it for. And so we've got a lot of other initiatives internally where we're pulling that data in. We're also using Spark internally with our Spark connector to do some of
Hmm.
our own kind of machine learning optimization reporting and things like that. And so I think there's just a set of use cases there that are going to continue to grow. And I think as people have more cycles to be able to move on to some of these optimization things and start to pull observability
Right.
into more of a business centric use case, we're going to see that where it becomes a focus from oh, well, how do I use observability to optimize my gross margins or my cost of goods sold. Like it's all technology under the hood. And so I think anytime that's true, observability can play a role in making the business more effective.
Yeah, and you made an excellent point right there where you said when people have the cycles to look into this stuff. I mean, most of the time, what are you doing in a business? You're just making sure the trains run on time. That's like 90+% of what people are doing on any given day in any given organization. And especially when the economy shrinks a bit, when there's pressure in the market, well, you have less free time, if you will. It's not even really free time, it's exploratory time to look at it. But then as these numbers rise, and I did a chat GPT search while we were talking here. I'm like, how much revenue did Amazon get versus Microsoft versus Google last year? And I'm impressed at how far Microsoft has come. I mean, Amazon had a 10-year head start on the competition, which is really mind-boggling when you think about it, that it took 10 years for the other guys to go, hey, I guess they're onto something. Let's go focus on that. But according to this, I just did 107 billion for Amazon, 102 billion for Microsoft, and 48 billion for Google. Folks, that's over $250 billion in revenue for these platforms. So all of a
per
sudden,
year.
and you got me excited about this, thinking this whole observability side of the equation, these are what your IT operations people are doing all day long, is trying to figure out what's going on. Systems are going down, clusters are failing, all sorts of stuff is happening. I mean, I remember watching some of these guys at Splunk, and I do not envy that job. Like looking at all these metrics and tracers and things, and like, okay, this is not a problem. This is a problem. I'll focus on this for a while. It's wild. It's crazy what you could do. But then the exciting upside for me is model training. And I'm not just talking large language models, I'm talking traditional deep learning modules that you can set up to track things like observability and to for like security purposes, right? Because the tools themselves have all sorts of capabilities for being able to identify patterns and say, okay, here's this pattern again. We're pretty sure it's this, this one problem that we've seen before. But if you train a model properly, it can solve all kind of problems for you. The key is you have to have the time to do it. You have to have the resource. You have to have the data, and you have to have the gumption to go ahead and make that happen. Right, Todd?
That's right. Yeah, and I think you're totally right that there's like I know LLMs are all the rage, and there's been a lot of stuff that's been very cool that's happened in the last few years, but these traditional deep learning models have been around for a long time, and so and I think the heart of any one of those is data, and so I think some amount of this is now that we've got these huge data repositories in the form of logs and observability data, and now we've got the tools to be able to go. And I mean, I'm obviously going to say hydraulics here. Like, you
Right.
can now keep and query in real time against months or years of data, and that is a really important part of being able to do a lot of this model training. Is you need to have a place where that data lives and a place where you can get access to that data quickly to be able to do this model training, and even some things like in LLMs like RAG, retrieval augmented generation, we see this with there are a lot of like vector search products that were very hot for a while. I mean, at the end of it, it's like how can I quickly get the data that I need in a format that I can use to either train a model or augment, a prompt. And so I think it's going to be it's something we get asked about all the time. And I think in a lot of ways it's still relatively nascent for a lot of these companies. They're still
Hmm.
working with the early stages of incorporating LLMs into their products, into their businesses, into their workflows. But I think we'll see more and more of it. It's obviously going to get better and better. We had the DeepSeek thing earlier this year, where it was like,
Right.
oh, you wake up one day and suddenly everything got 10x easier or 10x more efficient.
Right.
And I think we'll also see a lot more in the agentic AI space where yeah,
Yes.
it's using some amount of LLMs and some amount of other things for you to just be able to have an agent that's either looking for a pattern or looking for a trend or something that you can ask a question of and just say like, hey, this system isn't working, why? And it can say like, oh well,
Right.
I see this log over here and this log here.
Right.
Here's some things to investigate. And that's something that I think we're just in the very early stages of, but it's totally possible with the technologies we have out there right now.
That is such an I'm really glad you said that because we'll pick this up in the podcast bonus segment. I've had the same exact thought myself because these language models, you can throw log files into them and say, "Hey, what the heck does this mean?" And it'll come back. It may not always be correct, but it will give you really good information. So, like these LLMs, they are another layer in a very robust stack these days to be able to do analysis and get the answers in human readable text, which is like really, really important. Well, folks, podcast bonus segment is coming up next. Stand by. You're listening to Inside Analysis. All right, folks, time for the podcast bonus segment here on a fascinating show with Todd Persen. He is with Hydrolix. That's Hydrolix. Look them up online. Look Pearson, Persen. Pearson. It's Norwegian, I'm told. They were voyagers, right? The Norwegian folks. They were getting on ships, going all over the place, checking out the world. And that's kind of where we are today with these technologies. I mean, I think about these language models, and one of the immediate epiphanies I had the second I started using ChatGPT whenever it first came out was, if they can speak English and French and German, I bet they can speak HTML and Java and COBOL and these other things. And someone was telling me that I think it was COBOL that it was not trained on. So it wasn't trained on this language, and yet still it knows the language. You're like, huh. That's pretty interesting because it's just pattern recognition. And this is the thing that I think people have to wrap their heads around. This is what really was my aha moment with these is that unlike a database where you're actually persisting specific strings of text or numeric values that you will then pull back later and you want to get exactly what you put in, that's not how these things work. It's really kind of a lossy process because you're converting text and imagery to vectors and then back to text or imagery, which itself is a lossy process because you can't crunch letters, but you can crunch numbers, right? So there's that. But they're good at pattern recognition and all kinds of pattern recognition. And, when I sat there and thought about it, I'm like, the English language is pretty darn complex. I mean, there are, I can't remember how many words, a whole ton of words, and all sorts of different formats and syntax. And some of the smarter people I know have told me that the syntax was easy. I was like, really? I said, yeah, the syntax is pretty easy. And even ingesting massive amounts of text these days is not all that hard. But my thought I'll throw over to you just for some comment there is, system to system conversations are nowhere near as complex as human conversations, it seems to me. And so we should be able to get some really good insights into how these systems are actually working. Like you talked about I/O, like with an SSD, you have fewer I/O problems. You don't have to hit the network, stuff like this. Those are really important, especially at scale when you're talking about massive amounts of data flying all around, right? What do you think?
Yeah, and I think, for better or worse, I think, a lot of uh systems to date, and I think a lot of probably what, when we look at technical examples, what some of these LLMs have been trained on is relatively structured. And so I think one of the things that we're seeing, and we started talking about it a little bit already, is like, you're not going to be able to take, um, like back to our example of, hundreds of terabytes a day, like you're not going to feed that into an LLM. You're not going to feed that into Chat GPT and be like, here's, a terabyte of logs. What do I need to
Right.
see? So there's
Right.
going to have to be some, some balance between, a traditional model, deep learning model that's sort of like trained on a set of sort of like baseline logs. And then there's going to have to be some piece of it that's also coming from your LLM where it's doing the, you're asking it, English questions, and it's needing to do some insights, and somewhere, we need to be able to pair those things up. And I think, at the end of it, for any system to be able to give you like relevant answers, it still needs to be able to go get that data in real time, get that structured data in real time, and
Right.
give you
Right.
those answers. And so I think we were saying a little bit earlier, but like the tools are there. There's still a lot of stuff that we haven't really built or like totally glued together yet. But I think, yeah, we are benefiting from a lot of like this well structured data that we've been able to train on. We do have the ability to store and query this data at scale, and so now there's sort of this emerging opportunity where we can take these systems and put them together and really like it's sort of like we're using these tools to start to build, uh humanish agents. Like think about like, okay, I'm an operator. What do I do? Like I get an indication that something is wrong, and then I go do an investigation. And so being able to sort of like have a prompt oriented way of
Hmm.
guiding an AI agent through some of these workflows and doing that deeper investigation. And so I think that's something that's, obviously still very early, not something that we're like, we don't have anything close to a product in, but it's something that's on our radar for sure. It's something that we're really excited to start looking at, because again, you're coming back to the beginning of the conversation. It's all about the data. Like
Right.
if you don't have the data, none of this is going to work. So now that we've got a lot of those data challenges solved, what do we do next, and how do we actually really start to bring drive that value, and be able to, actually replace some of the humans in the loop, in a way that
Yeah.
we can trust and get value from.
Yeah, that's such a good point, and I'll just throw this closing comment out. There is, I think, an almost incalculable opportunity cost by not saving the data, because it changes how the human thinks about things. If you know there's data here, you will fathom to go look at the data and play around, and that door is open in your mind. Whereas if you don't have the data, that door is closed in your mind and you just look other places and do things other ways. And so to have that, and I'm not saying save data for saving data's sake, but still, especially with this kind of observability data that is showing you what's really happening in these environments, which are outrageously complex. I mean, they're already at hyperscale, so they're already so complex that no human can really wrap their heads around it. But if you have that data, if you have that observability data, then you can train models, you can optimize your performance, you can optimize your environment, you can improve uptime. All these positive things can happen if you have the data. But if you don't have the data, you're not going to do any of that fun stuff. Well, folks, look this gentleman up online, a fantastic conversationalist, Todd Persen, Persen of Hydrolix. And send me an email if you want to be in the show, info@insideanalysis.com. We'll talk to you next time. You've been listening to Inside Analysis.